Coloring Crypto.
We've got a back-to-back episode today on Coloring Crypto. The second portion is a paid promotion by our new client, Intiva Health. But we start with something brand new, super exciting, super hyped, Hashgraph. So the tagline at Coloring Crypto has always been, we illuminate the blockchain. But if our next guest has anything to do with it, we're going to have to change that to illuminating the distributed ledger technologies. All right, let's get into this. Paul Madsen, thank you for coming on Coloring Crypto. Paul, you are with Swirlds, who has come up with Hashgraph. Now, I sort of feel like I was just getting a grasp of what the blockchain is, and now you guys come along with something much better.
Sorry.
Could you give us a quick overview summary of what is Hashgraph?
Yeah, and thanks for having me, Gabe. What we're trying to do is the same as what blockchain does or aspires to do. And that is to allow some set of people on the network or computers or nodes in general is to come to an agreement or come to consensus on the state of some set of transactions, right? Whatever the nature of that transactions, whether it's you're moving currency from one wallet to another or moving files around. So we are like blockchain, a consensus algorithm or a consensus protocol. We just take a different angle on it. We make different assumptions about how consensus is best achieved, and just kind of the nature of how we work, we run faster than blockchains, particularly proof of work based blockchains like Bitcoin and Ethereum.
I think that's something that our listeners will very easily understand, is that I think most people at this point clearly get the problem, or one of the problems with the blockchain is when it's a proof of work model, it's just really slow. And so clearly if you guys have something much faster, that's going to be likely welcomed.
Yeah, I think so. But, be fair to Bitcoin and Ethereum. They've got proposals and a roadmap by which they argue that they're going to address some of the scaling challenges, right? So Bitcoin's 3 transactions per second, Ethereum's 15 in that ballpark. So both communities have mechanisms that they believe will increase those numbers, and that's great. We still believe that the sort of throughput that we can provide, and our tests validate that, is orders of magnitude larger. But almost maybe even more important than those quantitative differences is the qualitative differences between the nature of our consensus and that of a blockchain. So specifically, we are Byzantine Fault Tolerant, right? Which means that the consensus we deliver, or our protocol delivers, there's no sort of probabilistic, hey, I feel really good about this, give me another 30 minutes and I'm going to serve that coffee up in the archetypical use case of buying a coffee at a coffee shop. And with Bitcoin, you got to wait an hour before the barista actually has any confidence that the coins have been moved. With us, 2 differences. Because of the speed, the latency, that delay between, hey, I want a coffee and, okay, I'm willing to pour it, is seconds. And, on the qualitative side, it's a certainty about the confidence when that barista wants to pour the coffee. It's not, hey, I'm okay with this risk. I'm not totally confident that I might lose this $4 for a double latte, whatever it is. In our consensus, when that barista gets the green check on their app, that means pour the coffee. You're never going to risk that because consensus is final.
I understand, a lot of the terms we're going to be using to describe this, like the one you just mentioned, like the sort of Byzantine problem, gossip will come up. These are terms that are known within sort of, computer science and developers. Could you sort of describe the Byzantine issue and sort of how that relates to Hashgraph?
Sure. So Byzantine, in the context of consensus algorithms, is a reference to kind of a thought problem posed by some computer scientists about 30 years ago. And they presented the problem of consensus, of distributed consensus that we're all concerned with now, in the context of a bunch of generals with associated armies sitting around or encamped around a particular city that they're trying to attack. The challenge for those generals is that they all need to do the same thing. So the numbers are such that if they all attack, they're going to swamp the defenders and win the battle. But if only half of them attack, then the defenders behind their walls are going to have the advantage. So the critical decision for those generals, separated by a couple of miles across the battlefield of uncertain terrain where any messengers that they might send between themselves might be captured or killed or defect. The challenge for those generals is, how do we come to a decision, either attack or retreat, in the face of uncertain messaging, uncertain loyalties? How do we make the right decision? How do we come to a consensus decision about an attack or retreat in the face of all these difficulties? So that's the reference to Byzantine, right? Because for whatever reason, these computer scientists presented it as Byzantine generals.
So they've all got to decide, they're isolated with communication. They've got to decide in the same manner. All the actors have to do the same thing.
Exactly. That's the challenge, right? And that's really what the challenge we face nowadays when we're trying to decide whether or not to pour the coffee, right? That barista or some computer on their behalf has to work it out with a bunch of other nodes that the guy trying to buy the coffee has enough coins in his wallet to cover the cost of the coffee. So it still comes down to a community trying to collectively and collaboratively make a decision, go or no go. And Byzantine has kind of morphed into meaning evil or malicious. So a consensus algorithm, if you want to put it on the public platform, if you want to make a public platform out of it, you have to anticipate that some of your nodes, some of the participants will be malicious. They'll be evil. They'll be Byzantine. And so that's one metric by which we can measure a consensus algorithm. How well does it do against Byzantine actors who are actively trying to subvert the consensus, stop the consensus, or probably skew it to their benefit, right? And the kind of the archetypical example for cryptocurrencies is a double spend, where I'm a bad guy and I send you 5 coins. I've only got 6. I send you 5, and then I immediately send 5 to somebody else, and hopefully through my manipulations, I can effectively spend 10 coins when they only had 6 and get 10 coins worth of value back. So all of that to set the context that Byzantine is bad. And Byzantine fault tolerance, with respect to a consensus algorithm, means something a little bit more specific. It means, kind of in the broad sense, that, yeah, you can deal with bad actors, and mathematically it's provable that no consensus algorithm can deal with more than a third bad actors. If you've got 34% of the community and they're bad and you control them, then you're in charge. That's just the reality of dealing with these constraints and these circumstances. So yeah, every DLT confronts 33%. It's a law of nature, and that's been proven. We do too, to be full disclosure. We, like every other DLT, if 33% of the nodes on a Hashgraph network are colluding inappropriately and maliciously, then all bets are off.
Just to clarify for listeners, DLT is a distributed ledger, which is blockchain, and also what we're going to be talking about today is Hashgraph.
Yeah, so DLT is kind of the broad umbrella term. To be fair, some in the blockchain community kind of reject that because I don't blame them. They want blockchain to be the generic term, whatever, right? We're all referring to the same thing. So Byzantine means bad, and Byzantine Fault Tolerant means being able to tolerate, to a certain extent, bad faults or bad actors. But the other aspect of BFT, of Byzantine Fault Tolerance, set out in those original papers was that it also made requirements or stipulated the nature of consensus, that it can't be probabilistic, it has to be final. So if you think about it, you've got these generals sitting around their campfires sending messages back and forth, and they're trying to decide whether to attack on the next day. It's not a lot of help to them if they sort of have an 80% comfortable feeling on the morning, that, I think the other guy's going to attack. That might work, but 20% of the time, they're going to get crushed by those defenders, right? So BFT means that when you come to consensus, you won't change it because it's mathematically guaranteed that others will come to the same conclusion as you just did. It's a very different nature of consensus than that which blockchain, and just how blockchain works, right? You're adding additional blocks every 10 minutes, and it's that mechanism of sort of piling on that gives the community confidence in the earlier blocks. The deeper in the chain a block is, the more theoretical the risk of it being rolled back, but it's always there.
Okay, so this is great. So let's see if we can explain, or if you can explain, how does Hashgraph work to come to consensus and be Byzantine fault tolerant?
Sure. So we start with the assumption that you've got a community, a bunch of nodes, and by definition, every one of those nodes needs to learn about some fact, some happening, some transaction. So we start with the assumption that if I pay you 5 coins, I'm going to tell the community that I did that as the first step in ultimately getting that transaction recorded into the sort of collective memory, the collective state, the ledger. So we use a gossip protocol as the means by which one node tells everybody else in the community some fact, that transaction that I just gave you 5 coins. And gossip, is a well-established messaging pattern. We didn't invent it. Bitcoin uses gossip as the means of distributing transactions, and then once a block is mined, distributing the blocks back in the other direction. And they chose it for the same reason we did. Gossip is fast and resilient to faults. It's just an efficient way of getting the news out. But of course, getting the news out isn't enough, right? Because not only does every node need to know about the fact that I paid you 5 coins, for a lot of applications, a lot of use cases, the nodes also need to agree on a time at which that event happened or which that transaction happened, right? Because particularly if they're trying to spot double spends, if I sent you 5 coins, but I sent Dan 5 coins half a second earlier, he should get the money and not you, or vice versa.
Right.
So that's the challenge, right? I sent this transaction out to the community through gossip. It gets out to everybody pretty quick, but everybody receives it at a different time. They actually receive that message at a different time just due to the nature of gossip and messaging delays and firewalls and the reality of networks. So for Hashgraph, the challenge is we want to give the transaction of me sending you 5 coins a time that everybody can agree on. And if everybody can agree on times for each transaction that is flowing around the network, then everybody would be able to agree on an order for those transactions. And that's the Holy Grail, right? That's what consensus is about. Everybody agreeing on the order in which a set of transactions happened. Necessarily, are they good? Did they, were the signatures valid? Did they spend more money than the wallets had, et cetera? But fundamental is getting them into an order. And that's what Hashgraph excels at. The elegance of Hashgraph is that we just say that transaction flowed out to the community everybody received it at a given physical time based on when they received it over the network, we're going to give to the particular transaction just the median value of all the times that everybody received it, right? Just a very simple calculation. If some node received it 7 Eastern and some node received it at 5 minutes after, hopefully not that slow, and other nodes all received it at a given time, we're just going to put those times in the list and calculate the median. We're going to take the middle. And that serves to mitigate the effect of slow pipes or fast pipes or malicious nodes. We're mathematically guaranteed that the time we give that transaction will be either from an honest node or between 2 honest nodes.
How many nodes are required?
Well, the more nodes there are, the more resistant you are to evil nodes, right? If you've got 3 nodes, 1 node being bad shuts you down based on the math we talked about earlier. If you've got 1,000 nodes, then your tolerance is higher because you're resistant to Byzantine faults, like we talked about earlier, unless 333 nodes are bad. And it's harder to get 333 people cooperating than 1 or 2. So there's safety in numbers.
Is there a required minimum, or is it sort of a degree of trust?
Well, so we can be deployed in a permission network, and that's where we've started our business, where in a permission network, everybody knows everybody. That's not to say they trust each other, but they at least, maybe they've signed business agreements, they're business partners, they're banks, they're credit unions. So there are other mechanisms surrounding consensus to mitigate the risk of bad behavior. So in those deployments, you could have 3 or 4 or 10 nodes, right? And still be reasonably confident that 1 node is not going to corrupt consensus, or if they do, at least you're going to spot them and kick them out, right? There are mechanisms to mitigate it. In a public ledger, well, then you've got to deal with the possibility of anonymous nodes where they can join freely. You don't know who they are. You have to assume they're bad, and you protect yourself against those. So in those models, you want hundreds, thousands, ultimately millions of nodes.
So it's up to whoever's implementing the particular Hashgraph solution to determine that sort of parameter.
It's the community, right? It's always going to be the case that the more nodes, the better. In certain deployment models, you can better deal with smaller numbers of nodes.
So that's an example. If, let's say I'm sending money, am I counted as a node? I guess what I'm wondering is my timestamp that happened, does that get included in the group of timestamps where you're sort of grabbing the median time to mark down as the actual time?
So it may well factor. So the Hashgraph algorithm is pretty lightweight, right? It's nothing like the proof of work intensity of Bitcoin, right? So your computer could run a Hashgraph node if you had any sort of reasonable high-speed internet and any sort of reasonable CPU and storage, right? So your home computer, even your phone, modulo bandwidth, could probably run a Hashgraph node. So in that case, if you initiate the transaction and you are a node, then your timestamp, your representation of when you think that event happened, that's going to be counted in the list of times that we're going to include when we do the median. And by definition, it's going to be the earliest, right? Because you were the first in the community to know about your send money transaction. But because you might be motivated to cheat and change your clock in order to get an earlier timestamp so that your bid of buying stocks gets recorded into a distributed exchange earlier, we don't place a lot of trust in the timestamps that you inserted in your own event. We look at it and we count it, but it's that first in a list of, maybe 1,000 other nodes, all of which are saying, well, that's interesting, but I think this is the better time for this event. And the nature of a median means that if you're first on the list, whether yours is 10 seconds earlier or a microsecond earlier, it doesn't skew the eventual median timestamp. It's the middle. So taking the median kind of rejects the outliers on either end and disincentivize anybody trying to cheat on those values.
And whereas with like Bitcoin and the blockchain, those nodes are referred to as miners. What are these nodes in Hashgraph referred to as, and are they getting incentivized to be a part of this?
Yeah, it's a different model, right? If you think about it, we pay miners and we give them block rewards and fees because they're doing something that is extra to them participating in the network for their own needs, right? In Hashgraph, the expectation is that the node is contributing transactions into the network, either for their own benefit or for their clients. So there's kind of a concept of light clients that are able to interact with the ledger, but not directly participate in consensus and contribute to the consensus. So, we talked about a phone being able to run a Hashgraph node, and that's possible, but arguably more likely is that I have an app on my phone, and through HTTP RESTful APIs, I interact with a full node of the Hashgraph network. And I logically ask that node, hey, add this to the ledger, please. Do it on my behalf. And in that case, we think it's reasonable that I, the owner of the wallet app, pay that node for their effort, give them a fee. Now, to be clear, because they're doing not very much, it's not like they're spending 10 minutes on a proof of work calculation. I'm going to pay them a thousandth of a cent or whatever micropayment the market ultimately comes to. I'm rewarding for them or paying them for their effort, but it's not a lot of effort, so it's not a lot of payment.
I'm curious about the whole concept of centralization and decentralization as it relates to Hashgraph. And I'm wondering if the right way to ask that question is to understand Swirlds, the company that you work for, and the relationship to Hashgraph, sort of, around, is it going to be open source or sort of, what's that structure like?
The founders of Swirlds invented Hashgraph, and those founders have a patent over the algorithm. And when Swirlds, a software company, sells the Hashgraph algorithm into large enterprises for deployment in permission networks like I described before, then Swirlds, like any other software company selling in enterprises, charges those large enterprises a fee for the use of their licensed software. So that's kind of traditional software licensing, and that's how we've started our business on the permission network side. Now, a public ledger is a different proposition, right? That a public ledger, as I said, presumes an ecosystem where anybody can run a node. We want that. That's healthy for security and all the associated benefits, where anybody can hopefully build an application on top of that public ledger, a distributed app that avails itself of the consensus. So for that permissionless or open public ledgers, we haven't yet announced our strategy. There are indications that we may well soon be announcing that strategy. And what I would say is that, like anybody else announcing a public ledger, we want developers to be able to freely build on that ledger with no cost, to make their own licensing decisions about whether what they build is open source or proprietary. We want a healthy ecosystem of applications built on that with the same confidence about the licensing model. But yet I would say that we look at the forks of Bitcoin and Ethereum and of that community, the public cryptocurrencies that we've seen so far over the last 10 years. And we would suggest that there's a valid point in the space where we can encourage stability and confidence and trust in that public ledger, one that arguably would be better served by a licensing model for the software that inhibited forks rather than encouraging. I think historically, open source software has been a great model for encouraging innovation and incredible development. And yet, when you marry that with cryptocurrency, it hasn't been all good. The incentives change, the dynamics change, where in traditional open source software, arguably the incentives encourage people to work together. When you have an open source cryptocurrency, arguably the incentives encourage people to fork and clone and create their own coins and do an ICO and see how much money they can make. We see value in a sort of a more stable model.
Are you able to discuss some of the companies that you're working with?
Well, we've been very public about the companies on the permission side that have, as I said, purchased licenses to build out their own distributed application platforms on the permission side. So 6,000 credit unions formed a consortium called CU Ledger, Credit Union Ledger. And CU Ledger was our first notable success. So a bunch of banks coming together and seeing the value in Hashgraph relative to other DLT tech and buying a license. So they're building out that platform. More recently, Intiva Health is building a credentialing and an identity management platform for health professionals and building that on top of our consensus algorithm.
Cool. Do you have a sense of the roadmap for when those, when Intiva, when 6,000 credit unions, when they'll actually be able to deploy this and be, sort of fully functioning?
So I don't have a good sense. They're customers. They buy our stuff and then they have their own timelines. My sense is that CU Ledger is kind of in the POC phase with a smaller group of credit unions. I think 20 odd credit unions are proofing this out amongst themselves. Hashgraph has a Telegram group. One of the key architects of the CU Ledger was recently on our Telegram group, kind of doing an AMA. And it said some nice things about the speed results that they're seeing from their early testing of Hashgraph.
In your sort of wildly optimistic dreams, if we were to jump 5 years into the future, what does a great outcome look like? What kinds of impacts and changes do you anticipate?
So I think the use cases that we're used to talking about with DLTs, use cases that Bitcoin and Ethereum and others in the space have pioneered, admittedly pioneered, we want to address those use cases. We think we have technical advantages that would allow us to address them and make them more practical and viable, speed if for nothing else. But we also think that some of our advantages or features relative to other DLTs are, as I hinted at before, are qualitative and not quantitative, right? So we talked about BFT, and for many, that's huge. The security and the guarantee that gives you allows you to build applications that you otherwise wouldn't. Another qualitative feature of Hashgraph is what we call fairness. As the name would suggest, the inability of any small number of actors to unduly influence whether or not a transaction is even recorded into the ledger or the order in which it's recorded into the ledger. So Bitcoin, as powerful as it is, still gives to a miner every 10 minutes unilateral authoritative power over which transactions get added to that block and which don't. And miners are motivated to add particular transactions by the fees attached to it, right? But at the end of the day, a given miner is the one that decides what gets added to the block, and so what gets added to the chain and the ledger. That's not fair in the sense I've described, right? Different miners might abuse that opportunity to different extents, but they have the opportunity to unduly influence or reject particular transactions if they chose to. So there's a whole set of use cases that we don't think are even addressable by blockchain, right? Ones where fairness is critical. Stock markets, auctions, eBays, anything where two parties might be bidding on a particular resource and the order in which their two bids are placed or matched, that requires fairness, because if you don't have fairness, then no one would ever be willing to put a bid in there because they couldn't be confident it would be, not biased against. So we see a whole new category of applications, distributed applications made possible with Hashgraph that aren't addressable by blockchain and that similar architecture. So to your question, 5 years out, we want to be competing against the blockchain-based DLTs for a lot of use cases, and we'll compete there based on speed and latency and DFT. But we also think that we're uniquely positioned to go after that other set of use cases. So in total, we're optimistic about our ability to address a wide range of distributed applications in the future.
For the developers, the enterprise folks, and even it sounds like if developers can get their hands on this, is it going to be a similar set of parameters that people set when they're making an altcoin, on the blockchain, like maybe using Ethereum, where they can choose to set a max number of total coins, that kind of thing?
Well, so that presumes that a future Hashgraph ledger, public ledger, would have smart contract type functionality like Ethereum, ERC20 contracts. And that's a fair assumption. We aspire to be a full-featured public ledger. So we would expect and hope that others would build their own applications, some of which would be tokens or tokenized apps or cryptocurrencies. So yeah, we would expect a similar sort of dynamic of people experimenting on top of a Hashgraph-based smart chain platform, as opposed to Ethereum or EOS or any of the current options.
This has been very helpful for me. If listeners want to really dig in and understand Hashgraph, what are some of the best resources out there for them?
Well, two notable websites, swirlds.com, swirlds.com. There's a couple of white papers there that I think are very useful to if you want to dig into the details. Hashgraph.com. If you go there, you'll see a countdown timer to an event we're holding in New York in March 13th, where we'll clarify some of the things I've hinted at today. There's other information at hashgraph.com as well. YouTube is a great resource. The inventor of Hashgraph, Lehman Baird, has some really powerful videos on YouTube where he goes into great detail about how the algorithm works. It's if you want to, that's where I would start, those videos.
Awesome. So yeah, we'll put those in the show notes. If people want to find out more about the event in New York on the 13th, is that on hashgraph.com, or where do they go for that?
Yeah, I think hashgraph.com. They'll see the countdown timer, and they'll be encouraged to register. Whether or not they are attending, I think that'd be the best step.
Well, Paul, thank you very much.
Thanks for the opportunity. It's fun chatting.
Well, all right, Hashgraph. I think I kind of get it. I kind of get it. Let me know what you think. Do you think Hashgraph is going to be a potential replacement or worthy competitor to other distributed ledger technologies like the blockchain? please tweet us and let us know what you think. All right, next is our client, Intiva Health. They're the first product to get on Hashgraph.
Sure. So I'm John Hartigan, and I'm the Executive Vice President of Strategic Development and Partnerships.
Intiva Health is just one of a handful of companies that is this far along with Hashgraph. Do you guys think you actually might be the first to release?
It looks that way. There may be some other outliers that I am unaware of, but from what I understand, our platform, like I said, is already up and running, and in use. And to integrate the Hashgraph technology is a fairly straightforward process. And so, because we're so far along with our platform already, and that it's actually on the market, it looks as though we will be the first commercially available Hashgraph solution. Definitely in healthcare, for sure in healthcare, because we know that much. But it looks like it'll be wide as well.
Do you recall the first time that you heard of Hashgraph and sort of like what clicked in for you that this was special?
The biggest thing, really, I mean, this is what's most exciting to us. We have studies that just show that physicians are spending almost 9 hours a week on non-clinical paperwork. Okay, so non-patient paperwork, and those
9 hours a week.
Things. That's correct. 9 hours a week. It's a huge amount of time, and physicians as a group work long hours. Okay, and you give them back some portion of that, or 9 hours. Most of that has to do with compliance documentation, credential information.
What's the problem that you guys are solving?
A big part of a physician or other licensed medical professional, nurse, PA, nurse practitioner, is there is a very serious bureaucracy problem that they deal with for their credential management.
This is all old school paperwork, bureaucracy, layers that take a lot of time and overhead.
If you were to translate that, it's actually 8.7 hours a week is the study. And we did a calculation based on the providers, and it's something like $51,000. Oh, no, it's $59,000 a year based on the average salary of a provider. It's huge amounts of money.
So why not just digitize it and use a database? What's the benefit of a distributed ledger technology?
Oh, that's a great question. So we have a couple of different, there's really two concerns that we have. One is this is highly sensitive information. Providers, basically it's the provider's complete professional life is in our hands. All of that documentation. And so security is of utmost importance to us. Now, we currently have the highest level of security possible. That we use the greatest, government grade encryption that's available. However, we know from history, Target, and all of these others that it's still hackable. I mean, things happen, and so
look at Equifax.
Look at Equifax. Perfect example, right? And so, Intiva Health allows for a provider to have a digital place where they can store, manage, and share all of their credential information with their whichever facility they like. And by the way, this is free for providers to do this. And they can then stay organized. It also has an alert system to keep them compliant so they know when things are going to be coming up for renewal, and allows them to gain privileges much faster. And with this Hashgraph integration, we will be able to provide instantaneous credential verification because of the capabilities of becoming a house of trust, in essence, because of the immutable timestamps that will be available to us, and that will speed up the process from potentially months in some cases to seconds. And it will completely cut out that need for the analog solution that is in place now.
For folks who are listening who want to find out more, what should they do? Where do they go?
IntivaHealth.com, INTIVA health.com. Wonderful resources there. You can find out what's happening. We encourage you to, whether you're a medical professional or not a medical professional or just interested in blockchain and decentralized ledger technology, please sign up for more information. We have some great, interesting announcements coming up here in the next week or two, and we're extremely excited about what's going on. And things are moving fast, so get on our list so you can find out what's happening.
Awesome. Well, I look forward to talking to you in a couple of weeks. Sounds like there'll be a lot of good news to share.
Absolutely, and I really appreciate the time to talk with you guys, and love your podcast.
Coloring Crypto is brought to you by Affordable Jerseys, home of the player trade guarantee. Check them out at affordablejerseys.com. For a full list of our sponsors, go to coloringcrypto.com/sponsors.